Okay, chapter 4.4. So we're going to practice 6 problems from chapter 4.4. We're in the course, we're looking at your chapter review on page 511. We're going to start by looking at number 64. Instructions say solve each exponential equation. Okay, so we have, my book is far away from me, let me bring it closer. Okay, we have 2 raised to the 4x minus 2 equals 64. And my goal is to solve for x. So your goal is to solve for x. However, x is in the actual exponent. He's actually in the power, which means I need him to come down. I need him to come down. Now, I showed you a way in class where you can write, let me do it this way. B to the m power equal to b to the n power implies that m equals n. So basically, if you have the same base, so these are like bases. So if you have like bases, in essence, they cancel each other out, and your exponents or your powers are just equal. Okay? And we also talked about using the natural log. So if I have b to the m power equals, let's say, a. In fact, let's not use m. Let me use x. Let me use my variable x. So if I have b raised to the x power equals a, and I was trying to solve for x, well, remember, we could take the natural log on both sides. And by taking the natural log, the power now becomes the coefficient. So x times the natural log of b equals the natural log of a. And then you can divide by the natural log of b on both sides, because remember, natural log of b is just a number. So x would be the natural log of a divided by the natural log of b. Do you remember this property? You may use either one when working these problems. Now, you do not have to use this like basis. You can always use the natural log. But you may not always be able to use this method, right? The value on the right side may not be able to be written using the base on the left side. So in that case, you would have to use the natural log. So what I'm going to do is, for all of these problems, I am just going to use the natural log to solve them. Okay? So my x is in the power, so I'm going to take the natural log on both sides. It's the great thing about the natural log. I don't need to worry about trying to find a like base, raise it to a power, solve it, and all that. I'm just going to resort back to the natural log. Then once I do that, this power becomes the coefficient. So now I have 4x minus 2 times the natural log of 2 equals the natural log of 64. Well, the natural log of 2 is just a number, and he's multiplying, so how do I move him? I divide by the natural log of 2. So now I have 4x minus 2 equals the natural log of 64 divided by the natural log of 2. You'll be amazed at what this number actually comes out to be. And I need to solve for x. Well, like before, I'm just going to add 2 on both sides. Step's still the same. If you need to move something, do the opposite of what it's doing. So I have 4x is now equal to the natural log of 64 divided by the natural log of 2 plus 2. And what I'm going to do, I'm going to go ahead and work this out so I can get a number real quick. So hold on, let me find my calculator. Okay. So the natural log of 64 divided by the natural log of 2 plus 2 is, believe it or not, 8. So 4x is equal to 8. And I'm going to divide by 4, and I have x is equal to 2. And of course, you can check it by plugging it back in. 4 times 2 is 8. Minus 2 is 6. 2 to the 6th power is 64. Okay, so let's keep going. Number 66. This time I have 10 raised to the x power equals 7,000. And again, I want to solve for x. He is in the exponent, so I'm just going to take the natural log on both sides once again. Yes, I know you can take the log because it's base 10, but if you do the same method every time, you won't have to learn other ways. Stick with the natural log. The power now becomes the coefficient, so x times the natural log of 10 equals the natural log of 7,000. Well, again, I'm solving for x. He's being multiplied by this number, so I'm going to divide by the natural log of 10. Divide by the natural log of 10. And I have x is equal to, let's see here, natural log of 7,000 divided by the natural log of 10. And they tell me in the book to round to 2 decimal places, so let's say x is approximately 3.85, 2 decimal places. Good. Again, you're solving for x. He is in the power. We have the property that the natural log of a to the x is the same as saying x times the natural log of a. The power becomes the coefficient. Alright, let's see. Who's next? Number 67. And I have 9 raised to the x plus 2 equals 27 raised to the negative x. Now let me think. Using a natural log, would it benefit me here? I'm thinking. I'm going to do it just because I said I was going to stay consistent, and I'll show you how it turns out to be. Okay? Actually, you know what? It's more steps than I would like. But I'm still going to do it, and then I'll do it the other way as well. So let me change the color. If I take the natural log on both sides, this power becomes my coefficient. So x plus 2 times the natural log of 9 equals negative x times the natural log of 27. Great so far. Good. Now this time I have x on the right side as well as the left side. So it's not very simple where I can just divide by the natural log of 9 and solve. I actually need to get my x's together. But he's inside the parentheses, so I'm going to distribute my natural log of 9. And I have x times the natural log of 9 plus 2 times the natural log of 9. Okay, all you're doing is distributing. The 2 is on the outside. He's not inside this argument. Okay, equals negative x times the natural log of 27. Well, I want to get my x's together, so I'm going to subtract x natural log of 9 on both sides. And I have 2 times the natural log of 9 equals negative x times the natural log of 27 minus x times the natural log of 9. Well, now I have my x's on the same side, so I'm going to factor out the x, and I'm left with the negative natural log of 27 minus the natural log of 9 equals 2 times the natural log of 9. Now x is multiplying all of this, so divide by all of it. I think I need to move over, so let me move over. So I have x equal to 2 times the natural log of 9 divided by negative natural log of 27 minus the natural log of 9, which is, 1 second, 2 times the natural log of 9 divided by negative natural log of 27 minus the natural log of 9. And it comes out to be negative 0.8 or negative 4 over 5. Okay? So in this case, the natural log really wasn't a simple method, but I'm still able to do it. If you wanted to, you can resort back to the other way where your left side and your right side have the same base. So in this case, it would be 3 squared raised to the x plus 2 equals 3 to the third raised to the negative x. And remember, it's power to power, so it's 3 raised to the 2x plus 4 equals 3 raised to the negative 3x. My bases are the same, so they cancel. and just my powers are equal. And then you solve for x, and you'll end up with x equaling -4/5. Either way works. You must find the way that works for you. I like the natural log, but at times I see it can get hectic. So if you can write the left side and right side so it's the same base raised to some power, and then you set their powers equal. Alright, let's see what else we're going to work on. Number 74. Sorry, I lost my mouse. There he is. Number 74. So what do we have here? It says log base 4 of 3x minus 5 equals 3. And again, the instructions say solve each log function. So my goal is to solve for x, but he's inside my argument, which means I need to get him out, right? So I need to use the property log base b of a equals c is equivalent to b to the c power equals a. Base raised to the value equals the argument. Well, in this case, it's 4 to the third power equals 3x minus 5. Well, 4 to the third power, that's 64, equals 3x minus 5. Add 5 on both sides. You get 69 equals 3x divided by 3, and you have x is equal to 23. Now, because this is the log, you must always check it. So this is what I'm going to do to check. 3 times 23 minus 5, which is 64. This is a positive value. Therefore, this is a solution. And it works. Now, whether it's right or wrong, it all depends. I can't actually check log base 4, right? I actually can do it with the 64, but we really don't need to go through all that work. Our goal is to make sure that the argument is positive. That's all you need to do for the check. Alright, number 77. What do we have going on here? Log base 3 of x minus 1 minus log base 3 of x plus 2 equals 2. Wow. So we're solving for x. He's inside our arguments. There's 2 of them, right? So our goal is to go from 2 logs to 1 log. So we must condense this. So now let me change the color. I want to condense this. So let me remind you of the property. Log of a minus the log of b is the same as saying the log of a divided by b. So this is log base 3 of x minus 1 divided by x plus 2 equal to 2. So now I have a problem just like 74, and I must use the property 3 to the second power is equal to x minus 1 over x plus 2. And of course, let's go slide over. So we have 9 equals x minus 1 over x plus 2. Now you need to cross multiply. There's a 1 underneath here. And you end up with 9x plus 18 equals x minus 1. Subtract x on both sides. And you have 8x plus 18 equals negative 1. Subtract 18 on both sides. And now you have 8x equals negative 19. Negative 19 divided by 8, divide by 8. You have x equals negative 19 over 8. And you must check it, right? So you come to the first argument. He is x minus 1. So negative 19 over 8 minus 1 is the same as saying negative 27 over 8, which is not positive. Positive. It's not positive. Therefore, this is not a solution to this equation. Therefore, there is no solution. So there is no solution to this equation. Okay, one more to work on. Number 79. So we have log base 4 of 2x plus 1 equals log base 4 of x minus 3 plus log base 4 of x plus 5. Okay, so like before, we need to have a single log on the left side, and now notice that we also have a log on the right side. So let me remind you of this property. Log base b of a equal to log base b of, let's say, d. Well, when it's the same base, they in essence cancel each other out, and their arguments are left equal. Okay? So our goal is to have a single log on the left side and a single log on the right side. So we meet our goal for the left side. Is log base 4 of 2x plus 1. And also, let me draw your attention. The leading coefficients are 1. In order to do this property, your leading coefficients need to be 1. Okay, so now we need to condense the right side. So we remember that log of a plus the log of b is the same as saying the log of a times b. So this becomes the log base 4 of x minus 3 times x plus 5. Okay, well, they're the same log with the same base, so in essence that's gone, and just their arguments are equal. 2x plus 1 equals x minus 3 times x plus 5. Okay, let's solve for x now. So 2x plus 1 equals x squared plus 5x minus 3x minus 15. This is a quadratic, and with quadratics we move everything on his side. Now before I do that, I'm about to make the same mistake I did in class. Let me combine my like terms. So I have 2x plus 1 equals x squared plus 2x minus 15. Now subtract 2x on both sides and subtract 1 on both sides. And you end up with 0 on the left side, x squared, well, these cancel each other out, minus 16. So you can either factor it or go ahead, and since the middle term canceled out, at this point you may factor. You can graph and find the x-intercepts. You can also just add 16 on both sides since the middle term is gone. And you have 16 equals x squared. How do you get rid of a square? You take the square root. So the square root of 16. But it is a plus or minus, so I have 4 and negative 4 equal to x. Then like before, you always got to check this, right? So I can quickly glance up there and tell you 4 is okay. And you should be able to quickly glance up here and say, alright, positive, positive, positive. Let's check the negative 4. If I put negative 4 in here, that would be 2 times negative 4 plus 1. It's not positive, it will be negative. Therefore, negative 4 is not a solution. If you don't believe me there, you can do it here too. Negative 4 minus 3 is negative 7. Again, I cannot have a negative argument. So the only solution to this problem is 4. Alright, that concludes the video for 4.4. Let me know again if you have any questions.